Meaning of machine learning.
Machine learning can be defined as an approach to achieve artificial intelligence through systems or software models that can learn from experience to find patterns in a set of data. Machine learning, or ML, is an application of artificial intelligence. It provides machines with the ability to automatically learn and improve from experience without being explicitly programmed for it. It involves teaching a computer to recognize data patterns and create rules rather than traditional programming. The process of learning begins with observations or data, such as direct experience or instructions to look for data patterns. Let's take a look at a timeline of the evolution of artificial intelligence. AI gained popularity in the 1950s, while machine learning evolved around the 1980s. And it was until 2010 that deep learning emerged. Deep learning is a subset of machine learning, which is in turn a subset of artificial intelligence. To look at a real-time example, we don't need to go far. Google uses artificial intelligence and machine learning in almost all of its applications. Google Photos uses machine learning in Smart Search to display photos related to the keywords you search for and also animate similar photos from your existing albums into quick videos. The Smart Compose and the Smart Reply features of Gmail uses AI to suggest phrases and complete sentences when you draft an email or a reply. The Spam filter uses artificial neural networks to analyze and flag spam messages. Google Assistant has recently launched a new feature called Google Duplex that lets AI take over some real-world tasks, such as booking a haircut appointment over the phone. The Talk to Books feature lets you make a statement or ask a question and surfaces relevant passages from books through machine learning.
Statistical analysis.
Machine learning depends largely on data to study patterns. A large amount of data and statistical analysis of these data is required for machine learning. Statistical analysis involves collecting and scrutinizing the data sample to identify trends. A statistical model is a formalization of relationships between variables in the form of mathematical equations. While the goal of machine learning and statistical analysis may be the same, the formulations are significantly different. Machine learning is a subset of artificial intelligence in the field of computer science, while statistical analysis belongs to the field of mathematics and deals with finding a relationship between variables to predict an outcome. Machine learning is associated with high-dimensional data, and statistical analysis deals with low-dimensional data. So, what is the difference between machine learning and statistical analysis? Well, while machine learning takes away the deterministic function f out of the equation, statistical analysis tries to estimate it. Take a look at the table given here to the different naming conventions for machine learning and statistical analysis. Learning in detail. Machine learning leverages existing data, images, and videos to train algorithms and models. Numerous sets of examples are fed into the system, which are known as training sets. The larger the training set, the more accurate the algorithm would be. Each item in a training set is labeled as either 1 or 0. The machine learning process can be divided in two phases: training and testing. In the training phase, labeled data is fed as input into the algorithm along with the expected output, or labels. This is called the training data. The algorithm studies the data patterns and works out a logic based on an input and output training data. A machine learning model is derived, which can then be used with test datasets. In the testing phase, the test data contains only the inputs and the output is generated by the system based on the logic derived from the training data. The system classifies the test data based on the patterns learned from the training data. Then, the patterns from the test data and the logic of the learned model are used to make predictions and derive an output.
Types of machine learning.
There are four main types of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. The data modeling approach for machine learning is based on the structure and volume of the data at hand, regardless of the use case. Any of these approaches can be chosen after considering all the factors. Let's learn a little bit more about each of these approaches. In the case of supervised learning, the machine learning program is provided the training data along with the expected output or rules to categorize this data, which is also known as labels. The machine learning system uses the set of input and output to predict the output for future unseen inputs. It works well in classification. In supervised learning, it is imperative that the training data includes the desired output as well. Let's consider an example. In the first step, we supply photos of apples to a system, letting it know what apples look like. This is called labeled data. In step 2, the system learns from the labeled data, and the next time we ask the system to identify an apple, it is easily able to identify it. In unsupervised learning, the machine learning algorithm learns from an unlabeled dataset. Only the input data is used by the algorithm to train the model. The algorithm is expected to find patterns and anomalies from these input data. This method is mostly used in fraud detection, customer segmentation, and MRI analysis. Let's consider an example for unsupervised learning. In step 1, we provide the system with data that contains photos of different kinds of fruits and ask to divide it. In this case, we have not labeled the output data nor specified what the output data will or should be called. The goal of unsupervised learning systems is to understand and notice patterns, trends, and similarities from the given data. In the next step, the system will look for data patterns such as shape, color, and size, and then will group the fruits based on those features, attributes, or qualities. In a real-world example, Literati, the global database for litter, uses unsupervised learning to organize geographical litter locations through clustering. Training data includes some of the desired outputs. It is a hybrid approach and a combination of supervised and unsupervised learning. It uses a combination of labeled and unlabeled data. An example of semi-supervised learning would be how articles are organized into new topics on a web page. Let's consider an example for semi-supervised learning. In the first step, we collect and group labeled and unlabeled training data, after which we feed all the training data into the system as part of step 2. Reinforcement learning is a type of machine learning that allows the learning system to observe the environment and learn the ideal behavior. The learning system or agent observes the environment, selects and takes certain actions and gets rewards in return or penalties in certain cases. The feedback is given back to the system or agent in a loop. The agent learns the strategy or policy that maximizes rewards over time and tries to maximize the cumulative reward. Let's take a look into a real-world example of reinforcement learning. Robots are agents trying to manipulate the environment, which is a surface. This happens as the robot walks and tries to go from one state to another. It receives a reward for accomplishing a submodule of the task. In a manufacturing unit, robots use deep reinforcement learning to identify a device from one box and put it into a container. The robot learns by means of rewards-based learning systems, which incentivizes it for the right direction.
Algorithms of machine learning.
There are four main types of machine learning algorithms.